Hello. I am going to take you through quickly some of Lab 3. So here we go. I've loaded it up here. We're going to talk about mutating and filtering. This first block, you don't really need to understand it. This is what we're going to use basically any of the assignments. I'll include something like this at the beginning. If it doesn't have it, if you're making yours from scratch, you can just copy and paste this. I can quickly tell you what's going on. It's telling you where the root directory is, yes to include the code, loading the libraries that we'll often use, and also telling it to make a nice, clear background for our graphs and to use a sans serif font. So that's it. So let's run that. It'll just load everything up. And then the next idea, we will have talked about this in class, but is that we think of networks as two sets of tables, right? So one table is the nodes and information about them. So each row is a person, usually people for us. And so we might have their name and their age and their gender, etc. Another table is the edges, or in other words, the relationship between people. So this will almost, always have like a from column and a to column, who's the relationship originate from, who's it going to, and then some other additional information. So maybe it's the weight of the relationship, the strength of it. Maybe it's the type of relationship for a multiplex relationship. Is it friendship? Is it hatred? Etc. There are, in R, there are a set of tools for working with tables, right? People like me, scientists, do a lot of work with kind of giant tables. You might imagine a table that has, the path of an electron through space, or the path of a planet, or tables like mine might have all the comments that someone made on Reddit, and I might want to look at like how many they made over time, over each month or something like that. So there's a set of tools that's used to work with tables, filter out the things you don't want, or adjust things, or add a new column, that sort of thing. That's called the tidyverse in R. The rows in this kind of tidy data paradigm, each row represents an observation, in our case usually a person or a relationship, and each column represents some data, some metadata about that observation, some variable about it. Tidy graph is a package that extends this paradigm to working with networks. So like I said, networks are two tables, and then we can modify either of those tables, and then plot the network or calculate something about the network. We will use the Zachary Karate Club for this tutorial, so we'll load it. This takes the notable networks, and Zachary is one of those, and saves it as G. So when we look at that down here, I must have set it. It might show up here for you, or it might show up at the bottom. Either way is fine. If we look at the graph, it says right at the first thing, so this is running G that I just ran. The first thing it says is a Tibble graph. So that's what this is. It's a Tibble graph. It has 34 nodes and 78 edges. And then it tells us information about it. So here are our two tables. Node data is our node table, and there's nothing about the nodes right now. And then edge data is our edges. So this is all of the relationships between people. So the first relationship, node 1 is connected to node 2. Node 1 is also connected to node 3. Node 1 is connected to node 4, etc. And there's 75 more relationships. So now the first thing to understand is that because there's these two tables, whenever we want to do something, we need to let R know which table we want to work on. And activate does that. So we'll either say activate nodes or activate edges. In this case, so for example, we will mutate. We'll talk more about mutating in just a second. Adding a new column called degree to the nodes, or activating nodes. If we run that, we look up here now to our our node table, and now it has a column called degree. So we activated the nodes to tell R we wanted to work on nodes, and then we mutated. So mutate is it's a function that creates a new column in a spreadsheet or a data frame or a tibble. These are all words I may use that all mean basically the same thing, a table. So spreadsheet, data frame, table, tibble, those are all really pretty much the same, at least in the context of this class. Okay, so in our case, we're going to choose the nodes or the edges. You can also create other kinds of columns. So this one here calculates the degree of centrality for each node and then adds that, right? So if we look at it, this node 1 has a degree centrality of 16. They have 16 relationships. Node 2 has 9, etc. We can also add things like this adds names to the nodes for a random network with 5 people. So if we look at this, here's our node table. So this is a tibble graph with 5 nodes, 9 edges, and here are 5 people: Alfred, Bonnie, Clyde, Doug, and Enola. So we've just added names to it. And then we might write our graph, we might plot it with the names and show those. So exercise 1 is to take our earlier version, this one that creates a degree column based on centrality degree, and change it, so that you have a betweenness column that uses the centrality betweenness function. So you can copy and paste that from up above and then figure out how to make it calculate centrality betweenness. So if we look, once you're done with this, you should have that betweenness column if you run it. If you remember up above, we ran this G and added a degree column, and it shows up down here when we look at it. When we run it again, if we just run G to look at G again on its own, it doesn't look, our betweenness column disappeared. It doesn't show up anymore. That's because we didn't save it. If we look at our code, and probably your code and the way you did it, this takes G, and then this thing's called a pipe. Usually we call this character pipe, and then a pipe and this kind of greater than symbol. You can think of it, it's called a pipe because of the analogy there. It pipes the data. So it takes data, G, our graph, pipes it, sends that over to activate nodes, and then now we take just the nodes. We take that table and send it over to the next function, which is mutate. We add degree centrality, and then when we don't do anything with it after that, all it does is print it out. So it prints it out here, it shows it to us, but it doesn't do anything else with it. If we want to save it, we have to add this arrow at the beginning, right? So it's a less than and a minus symbol, and which it looks like an arrow pointing to the left. In other words, it says, take everything I'm going to do on the right side and save it as whatever's on the left side. So this takes G, activates the nodes, adds the degree column, and then saves it as G. So it kind of saves it over the top of the G that we had before. So now when we run it, it doesn't print anything out, because instead of printing it, we saved it. Now when we look at G just on its own, we see that it did save it and we have a degree column. So your next exercise is to figure out how that betweenness column that you created, add that to G as well. So when you're done, if you look at G, like if you ran this or just type G down here, it should have not just degree, but also betweenness. So that's your exercise. The next thing we're going to look at is filtering. So that's the one other thing for today. We might want to know about some subset of the nodes. We don't want to look at all of them. This is based on some attribute of the nodes. We might look, for example, at just the older or younger members of a group. We might look at just the network of freshmen or just the network of seniors, etc. So we're going to use something a little bit richer for this one because the karate data doesn't have any information about the nodes. So let's load the HT advice network. So this is based on the network data package. Hopefully you've got that all working. So network data stores things in iGraph format. And in order to do this filtering, we have to change it to tibble graph. So that's what this first part is doing. It says take HT advice, which we get from network data, and then pipe that over to as tibble graph. So convert it to a tibble graph, and then remember this left arrow, save that as HT advice. So what is that? I don't know if my arrows match up or if I'm mirrored, but you'll figure it out. You see what I'm saying? So save that as HT advice. So now HT advice is a tibble graph. As you can see, when we look here, it's got, the way you can tell is it'll say right at the top, a tibble graph. So that's how you know you've done it right. So it's a tibble graph, and we have age, tenure, level, and department. right? So that's great. And then there are 190 edges. We don't have any information about that. Let's plot it, we can make a figure of it. So here's our graph, our initial figure of all the members. Now we're going to filter that. So let's say we just want to see the sales department. I don't know what the departments are. They're actually just numbered, right? If we look at the department up here, department 4, but let's pretend like department 2 is sales. So we need to activate the nodes and then filter to those that are department 2. So when we're filtering, this involves some kind of comparison. So usually less than, greater than, or equal to. That's what this equal means. Oh yeah, in fact I should, let's preview this as well. I should have done that instead so you could see all of this. I guess it works either way. So I'll let that do its thing. While that's running, we can talk about this code. So we have HT advice, and then we pipe it to activate the nodes, pipe it to our filter to just the nodes in department 2, and then, oh yeah, there we go. Here, I'll zoom in as well so you can see this. And this is how this is a good way to do this, to do these homeworks, is to have the PDF on one side and your code on one side, and then this is a little easier to read, and you can, kind of go through it that way. Okay, so here we go. We made it through all of that. Okay, so we're filtering to just the department where department is equal to 2. If we want, so what I'm doing here is adding a print in there. You can actually print that, and it'll just print wherever it is at that point, and then we're also going to plot it at the end. And so this is the print part. It's printing the nodes and the edges. It's printing our tibble graph, and you can see department has 2, 2, 2, 2, 2, 2, 2. That's exactly what we want, right? Because that was what we said, is only save the ones where department is equal to 2, and it only has the 25 edges now. And so here's just department 2 and the relationship between the nodes in department 2. Great. And notice the numbers don't really correspond. They are just the first, because there's, renumbered them anyway, because we didn't actually have numbers attached to them. That's not super important. So, okay, next, your exercise is to filter it to just people who are older than 35. So the key thing you're going to have to do is look at the attributes of this, right? So the attributes are age, tenure, level, and department. Figure out which of those is the one you want to filter, and filter to people who are just older than 35. So now we have department 2, filter to older than 35, greater than 35, and figure out how many nodes there are, how many edges there are. And the way to figure that out, right, you might want to use print like I did, right? Note that when you use print, it says right at the top. So work on that. And then the next one, this is a trickier one. I'll let you search on the internet and figure this out, or try and goof around and try some things. But see if you can filter it to only nodes whose tenure is less than the median value of tenure. So here's tenure, right? We have 13 and 3 and 5. See if you can just do the newer people, the newer half of people, so less than the median of tenure. And then finally, the last concept that I will talk about, sorry, I'll try and use this one, is filtering, chaining these things together. That you can do both of these things in the same, kind of the same program. So in this one, the first example I'll give, we take HT advice, activate the nodes, filter to department 2, and then calculate betweenness only for the betweenness of people in department 2, right? So here's what we get, all of the betweenness for department 2. And then, right, we might want to, plot that, like maybe we'd make the nodes bigger if they had higher betweenness, but we're only concerned about department 2. And note that the order matters, right? If we ran mutate before filter, it would calculate the betweenness centrality before filtering. It would calculate people's overall betweenness centrality instead of just within the group. Sometimes that's what we want, right? So for the final exercise, when you do the same thing, except with degree centrality, so do it in the other order. Calculate degree centrality overall. So calculate that first, save it in a column called degree, and then filter to just the nodes with the degree of at least 2, right? So we have to filter, we have to calculate the centrality, we have to mutate first, because we're going to filter based on what we just mutated. So that's the last exercise. Good luck. Looking forward to seeing what you come up with.